want your program to repeat a block of code. You could copy and paste those lines of code, but what if you wanted to repeat 100 times or 1,000 times, or maybe you don't even know up front how many times you need it to repeat? To solve this, we can use a while loop. A while loop tells the computer to keep executing a block of code as long as a certain condition evaluates to true. We've used Boolean conditions before with conditionals. In a basic if statement, the computer evaluates the condition once, and if it evaluates to true, it executes any code indented inside of it. And then it moves on to execute the rest of the program. With a while loop, the computer evaluates the condition, and if it evaluates to true, the computer executes any lines of code indented inside of it. However, now that we're at what we call the bottom of the loop, the computer will go back to the condition and check it again. If it still evaluates to true, the computer will execute the lines of code indented inside the loop again. And so on and so on and so on until when the computer checks the condition, it finds that it evaluates to false. Only then does the loop terminate for good and the computer moves on to execute the rest of the program. In Python, the syntax for a while loop is just the keyword while, followed by a Boolean condition, and then a colon. Any lines of code we want to repeat inside the while loop, we indent one tab over. We call this the loop body. Because we want the loop to terminate eventually, we don't want it to repeat forever, we'll want the loop condition to evaluate to false at some point. Typically, that means our loop condition will include a loop variable, which is a variable that gets updated inside the loop body. On each trip through the loop, what we call an iteration, the value of the variable will change, which means that when we go to check the loop condition again, there's a chance it might evaluate to false this time. Let's take a look at our coin flip experiment. Here, we generate a random number between 1 and 2, and if that number is 1, we print heads, and if it's 2, we print tails. Now, what if I want to repeat that experiment to see how often I get tails? I can wrap my experiment in a while loop. So the first thing I'm going to want to do is figure out what my loop condition should be. Let's say I want to repeat this experiment 5 times. So my condition might be something like num flips less than 5. Then any lines of code I want to repeat need to be indented one level in. Well, on each iteration, I want to generate a new random number to simulate a coin flip, and then I still want to check if it's 1 or 2 and print heads or tails. So I'm going to tab all of these lines of code over. If I run this program now, I get a name error because the variable numFlips hasn't been defined. We never assigned it a value. With while loops, we always want to make sure we initialize our loop variable before the loop. Here, we probably want to initialize numFlips to 0 because we haven't done any coin flips yet at this point. We have 0 flips. Now that our name error is fixed, it looks like the computer's printing heads, tails, tails, heads, heads forever. This is what we call an infinite loop. Our loop never terminates because our loop condition never evaluates to false. If you ever see your program hanging like this, you want to press the stop button to recover and terminate the program. Otherwise, it'll keep running forever until the computer runs out of memory. So why is it infinite looping? Well, we never update the value of the loop variable inside the loop body. So numFlips always contains the value 0, which means every time we go back to the top and check the loop condition, we're checking is 0 less than 5, which will always be true. What we actually want is to increment numFlips by 1 every time we flip a coin. So we're essentially counting up the number of flips. So before the first iteration, numFlips will be 0, then before the second iteration it'll be 1, 2, 3, 4, until the check becomes 5 less than 5, which evaluates to false and the loop terminates. By convention, we update the loop variable at the very bottom of the loop so that it changes right before we go back to check the loop condition. Then we can increase our number of repetitions just by modifying this stop value in the loop condition, say to 100 or 1,000. So when you're writing while loops, make sure you check for all 3 key components: that you initialize your loop variable before the loop, that you check your loop variable in the loop condition, and that you update the loop variable at the bottom of the loop body. What exactly is happening behind the scenes when the computer executes a while loop? Let's trace a while loop step by step to find out. Before we start, let's see if we can get some intuition for how many times this loop repeats. To count repetitions, we just need to look at the loop variable, what value it starts at before the loop, what value it stops at to terminate the loop, and what value it updates by on each loop iteration. Here we see that our loop variable is called pin, and it's initialized to the empty string. The loop condition then is checking the length of the string pin, and it's comparing it to the number 4, which means this is the length that we'll stop at. Because pin is initialized to the empty string, we're starting out at length 0. Now we just need to look for how pin gets updated inside the loop body. The assignment statement here looks like it's concatenating a new digit onto pin on each iteration, so the length of pin would be increasing by 1 each time. So if we start at 0, we stop when we get to 4, and we increment by 1, this loop will repeat 4 times. Now let's double check that work by tracing the full execution. As usual, the computer starts executing at the first line of the program. Here we have an import statement, so the computer goes off and loads the code for the random module into its memory. This line initializes the variable pin. The computer goes off to its short-term memory, allocates a new chunk, stores the value, the empty string there, and then tags it with the name pin. On to the next line, now we've reached the while loop, so the computer evaluates the loop condition. The variable pin currently contains the value, the empty string, so the length of pin is 0. 0 is less than 4, so the loop condition evaluates to true. Because it's true, the computer goes on to execute the loop body. The loop body is any lines of code that are indented inside the loop. So the next line to execute is this digit assignment statement. We evaluate the right-hand side of the assignment statement first, which calls the randint function. Randint generates a random number between these two bounds. This happens randomly, so it'll change on each run of the program, but let's say it returns 0 this time. This is the first time we're assigning to digit, so the computer creates a new variable. Then we move on. Because this line is indented, it's still inside the while loop, so this is the next line of the loop body. We simplify the right-hand side of the assignment first, so we substitute in digit, which is the integer 0, and we cast it to a string, so we get the string 0. Then we substitute in pin, which is the empty string, and we concatenate together. We store that value back in the variable pin, overriding the previous value. Which line executes next? This print statement is not indented, so it's considered outside of the loop. It's not part of the loop body. That means we're at the bottom of the loop. So the computer jumps execution back to the top of the loop and checks the loop condition again. We substitute in the value of pin, which is now the string 0. We take the length, which is 1. 1 is less than 4, so the loop condition still evaluates to true. That means we're executing the loop body again for a second iteration. We generate a new random number, let's say 5 this time, assign that to digit, and then we update our loop variable pin. Pin currently contains the value 0, and then we concatenate on the string 5 to get 0, 5. We store that back in pin, and now we're at the bottom of the loop again. We jump back to the top of the loop, and we check the loop condition for the third time. Pin now contains the value 0, 5, so its length is 2. 2 is less than 4, so the loop condition is true. So we're entering the loop body again. We execute the digit assignment statement. Let's say we generate 9 this time. We store that in digit, and then we update pin. Pin is currently 0, 5. We concatenate on the 9, and then we store back 0, 5, 9. Back to the top of the loop, the length of pin is now 3. 3 is less than 4, so the loop condition is still true, and we start the fourth iteration. Randint generates a 5 this time, so we store that in digit, and then we go on to the next line. Pin is now 0, 5, 9. We concatenate on the string 5, and we store that back in pin. Once again, we find ourselves at the bottom of the loop, so we jump back to the top. We substitute in the current value of pin, which has length 4. So now our loop condition is 4 less than 4, which evaluates to false. That means it's finally time to terminate the loop. We skip the loop body and look for the next line of code that's not indented inside the loop. That's our print statement here. We substitute in the value of pin, concatenate together, and print that sentence out to the console. And that's the last line of the program, so the computer terminates execution. And we see that our loop body indeed executed 4 times. When we write a standard while loop, we need an assignment statement to initialize our loop variable to a start value, and an assignment statement to update our loop variable on each loop iteration. In many cases, though, our loops are just counter-based, which means that the loop variable counts up or counts down on each loop iteration to repeat that block of code a fixed number of times. To save ourselves some work, we can instead write these as for loops, which is just an alternate syntax for counter-based while loops. A for loop starts with the keyword for, then the name of the loop variable, the keyword in, and then the range function, ending of course with a colon. The argument to the range function is just the stop value for the loop variable, which tells the computer when to terminate the loop. This while loop and this for loop are now equivalent. They do exactly the same thing when executed. Note that with the for loop though, I didn't include these two assignment statements. I don't need to initialize my loop variable to a start value, and I don't need to update it on each loop iteration. The for loop statement takes care of all of that for us behind the scenes. That sounds like a lot of magic, so let's trace exactly what the computer does when it executes a for loop. First, the computer simplifies down any expressions in the for statement. Here, it first evaluates this range function call. There is some nuance here to exactly how range works behind the scenes, but these are just details to optimize for efficiency. For our purposes, we should just think of range as generating a range of values between a start and a stop. By default, the computer uses 0 as the start value. The stop value is the number passed into range. The start value is inclusive and the stop value is exclusive, so this is really the range 0, 1, 2, 3, 4, stopping before it reaches 5. On each iteration, the computer will set the loop variable to the next value in the range until it reaches the end. Then it terminates the loop. So before the first iteration, the computer will assign the value 0 to the loop variable pattern, because 0 is the first number in the range. Then it enters the loop body and executes the lines of code indented inside of it in order. So it'll execute this print statement and then this print statement. When it gets to the bottom of the loop, as in the last line of code indented inside of it, it'll loop execution back to the top. Then it picks up the next value in the range and assigns that to the loop variable. So pattern now contains the value 1. It enters the loop body again, executes this print statement, then this print statement, hits the bottom of the loop, and then loops back to the top. It assigns the next value in the range to the loop variable, and then it repeats. Pattern now contains 2. We do it again. Pattern contains 3. We do it again. Pattern contains 4. We execute the loop body one last time, and now when we loop back to the top, there are no more numbers in our range. So this tells the computer to terminate the loop. It skips the loop body and jumps execution to the next line of code outside of the loop. So our for loop with range 5 repeated 5 times, once with the loop variable set to 0, to 1, to 2, to 3, and to 4. Okay, but what if I want my loop variable to start at a value that's not 0? The range function can optionally take another argument to specify the start. If we don't include it, the start value just defaults to 0. Here, we now have the range from 1 to 10. So the loop variable would start at 1, then 2, 3, so on until it gets to 9, which is the last value before our exclusive stop of 10. Now that we can harness the power of for loops, why would we ever use a while loop? Well, all for loops can be expressed as while loops, but not all while loops can be expressed as for loops. For loops only work for counter-based repetition, when we know upfront how many times the loop needs to repeat. If our loop condition waits on a program state that involves randomness or user input, we may not know upfront how many times the loop's going to repeat, so we'll need a while loop to express that loop condition. But when we just need to repeat a block of code a fixed number of times, for loops are the fastest option because they collapse all of the loop variable assignments into a single line of code.